Alright, and here is our ACP domains of advanced rational functions. Now this one's ACP 2, and we want to find the vertical asymptote, horizontal asymptote, oh there should be a comma here, whole, and domain of the rational function. Don't tell your English teacher. Alright, so in this one we see we're given the function f of x is equal to 4x squared minus 12x plus 9, and on the denominator 2x squared plus 5x minus 12. Now, I have broken this up into 3 parts, and after we go through each part, then we'll go ahead and find the domain of that rational function. So, how should you view this? Well, you're going to have to use factoring by grouping on both the top and the bottom. We know we have to use factoring by grouping because we can't divide all 3 of these by the leading term, which is 2. Okay, so factoring by grouping, we know that this is A, we know that this is C, and we always start by multiplying A times C. Okay, so 2 times negative 12 is, of course, negative 24. Now, I take my very first term, my leading term, and I split it over to the right. I take my minus 12, I split that to the right as well, and at this point, I want to split this middle term into 2 terms. So, what 2 numbers actually multiply to be negative 24, but add up to equal positive 5? Well, if we were to do a positive 8 and a negative 3, 8 times negative 3 is negative 24, and 8 times negative 3 is positive 5. So those 2 numbers check out. Now this is where it gets a little bit trickier. Should I put the 8 with the 2 or the 12? Well, 8 has a factor with both of them, so it doesn't really matter. But what about 3? Does 3 have any factors with 2? No, it doesn't. So in this case, we'll put the minus 3x with the negative 12 by necessity, and we'll put the plus 8x with the 2. At this point, I can go ahead and do my factoring by grouping by splitting this up into 2 groups of 2 terms each. And I ask myself, well, what's the greatest common factor that I can pull out of 2x squared plus 8x? Well, we can pull out a 2x from both of these. So I'll write 2x, big parentheses. Over here, I ask myself, what's the greatest common factor that I can pull out of negative 3x minus 12? And of course, that's going to be a negative 3 and a negative 3. So I pull out that negative 3, and my remaining factors, well, 2x squared divided by 2x is just x, and 8x divided by 2x is plus 4. Similarly, negative 3x divided by negative 3 is just x, and negative 12 divided by negative 3 is a positive 4. Because, negative divided by negative is a positive. Now at this point, I know that I've done my factoring by grouping correctly because these 2 factors are the same. So I can say, okay, once I factor out the x plus 4 from both of these, my leftover factor will be 2x minus 3. Okay? Now I think the factoring by grouping is probably the hardest part of this problem. So let's go on to our part 2, which will be quite a bit easier. Okay, part 2 says this: find the domain of the rational function. And so we have f of x is equal to 1 over x minus 3. Well, remember this, you can never divide by 0. That is a big no-no. The reason is because that is what we call undefined in math. And particularly the reason we call it undefined is because what it creates is something that we call a vertical asymptote. Okay, so that means a vertical line that nothing can pass through. So in this function right here, we have f of x is equal to 1 over x minus 3. And we want to say, well, you know what? Where does x minus 3 equal 0? Because that is the value that x cannot equal. Okay, well, x minus 3 equals 0. Of course, I simply add, not 4. I add 3 to both sides. And of course, that cancels. And here it would say x equals 3, but we're really trying to find out the value that x cannot equal. And in this case, it is x cannot equal 3. What does that mean for my domain? It means that my domain literally exists everywhere else except for at positive 3. So I can say, hey, my graph will go forever to the left to negative infinity, all the way up to 3, and we use this little parentheses to represent it's getting very close to 3, but it actually cannot be 3. And then we actually join this with the right side of 3. We say, hey, there's a break at the value of 3, and then this goes on to infinity. Now, I give you the domain first to tell you you can get the domain by simply finding out the value that x cannot be and writing it as such. Real quick, though, what would the graph look like? Well, we go to positive 3, 1, 2, 3, and we can draw our vertical asymptote. Looks something like that. And notice there's no constant being added out here, so it's like saying plus 0. So we have a horizontal asymptote at 0, and since this is a positive function, our graph will look something like this. Okay? And you can see here, it's going forever and ever and ever to the left. There's our negative infinity. It's going forever and ever to the right. There's our positive infinity. And remember, as this graph is going towards negative infinity in this direction, it's actually getting really, really close to that dotted line, but it'll never touch it. So that's why the graph actually splits at this value of positive 3. All right, let's go and move on to part 3. Okay, part 3. How in the world do you simplify a rational expression? Well, you always simplify by factoring. That is our number one go-to. You want to factor the top and the bottom. So over here, let me just draw ourselves a fraction bar. And up a little bit above it, I'll put x squared plus 5x plus 6, because we want to simplify this rational expression. And down below, just a little bit off that line, we'll put x squared minus 9. Well, how in the world do you factor x squared plus 5x plus 6? Y'all know this. We're looking for two numbers that multiply to be 6 and add up to be 5. And hopefully you're thinking 3 and 2. So I can put plus 3 and plus 2, because 3 times 2 is 6, and 3 plus 2 is 5. Okay, now on the bottom we have x squared minus 9. Now remember, this is what we call a difference of squares. And all you really have to know is that so long as it's being subtracted, you can split this up into x plus a number and x minus a number. And that number is always the square root of the constant. And the square root of 9 is 3. Okay, so we've now factored it to this right here. And then the question becomes, are there any factors that actually reduce to 1? And you're just looking for factors that are the same. So in this case, x plus 3 on top, x plus 3 on the bottom. Those two things reduce to 1, so essentially they cancel. And would say, hey, the simplified form of this is x plus 2 over x minus 3, or the non-canceled out factors. Alright, well, at this point, we have parts 1, 2, and 3. It is now time for us to tackle this ACP problem. Okay, ACP 2. Find the vertical asymptote, horizontal asymptote, the whole, and domain of the rational function below. Now, the thing that I truly care about is the domain. That is our primary focus, is can we find the domain? And I want you to know these other things will just be kind of points of interest along the way. So how in the world do we find the domain? Well, of course, step number 1 is we want to factor. And notice, since we have leading coefficients, we ask ourselves, well, hey, on the top, can all three of those numbers be divided by 4? Let's see, 4 can, negative 12 can, but 9 cannot. So on the top, we're going to have to use factoring by grouping. All right, it's kind of our advanced version. And on the bottom, let's see, 2 can be divided by 2, but 5 cannot. So in both of these cases, we're going to have to use factoring by grouping. So here's what I'll do. I'll draw myself a little dashed line. Okay, and on the left, let's go ahead and factor out 4x squared minus 12x plus 9. And on the right, we'll do 2x squared plus 5x minus 12. Okay, so the first thing we want to ask ourselves, let's see, we drop our 4x squared, we drop our plus 9, and the question becomes, what two things are we going to split negative 12x into? Well, remember, you have to multiply 4 times 9, or A times C, and 4 times 9 gives you 36. And what two things multiply to be positive 36 but add up to be negative 12? And that one will be negative 6 and negative 6. So I got negative 6x and negative 6x. Okay, not too bad. Now at this point, I know that I want to break this up into two separate factors. And from this leading one, on our most recent test, I had a lot of students try to divide out a 4x. Well, can 6 be divided by 4? No. So you're trying to pull up the greatest common factor. What's the greatest common factor between 4 and 6? And of course, that's going to be 2 and 2. And both of these can give up an x. So we'll write this as 2x parentheses. And over here we have a negative 6x and a positive 9. And remember, if your leading term is negative, you must factor out a negative from both of these. And the greatest common factor of 6 and 9 is 3. Okay, so minus 3. And I might have made a mistake by having to squeeze this in, so you have my apologies. But it turns out 4x squared divided by 2x is just 2x. And negative 6x divided by 2x is negative 3. And over here, negative 6x divided by negative 3 is 2x. And similarly, 9 divided by negative 3 is negative 3. Okay, we barely made it legible. So in this case, because I have a 2x minus 3 and a 2x minus 3, I'm actually going to go ahead and start to rewrite my function where I draw my fraction bar. And one of my factors on top is 2x minus 3. And my other factor, once I factor those out, is 2x minus 3. Okay, so that's pretty cool. You had a perfect square. You could have actually written that as 2x minus 3 squared, but we'll keep it separate for now. Okay, let's go ahead and move on to our next target. So now we have the 2x squared plus 5x minus 12. Now we did this earlier in the video, so I'm going to move very quickly. A times c, 2 times negative 12 is negative 24. So what we can say is, hey, we have a 2x squared and a minus 12. And what two numbers multiply to be negative 24 but add up to be positive 5? And of course, that's going to be plus 8x and minus 3x. Now from here, I want to split this into my two factors. And the greatest common factor from both of these is, of course, 2x. So I pull out my 2x. And over here, negative 3x and negative 12, as we discussed earlier, we'll factor out a negative 3. And what in the world are my leftovers? Well, 2x squared divided by 2x is x, and 8x divided by 2x is positive 4. And over here, similarly, negative 3x divided by negative 3 is x, and negative 12 divided by negative 3 is 4. And so here, we see an x plus 4 is a shared factor, x plus 4. And our other factor, in kind of this, this blue, is our leftovers are 2x minus 3. Okay, so this is pretty tricky up till now. You have to use factoring by grouping twice, but once you do this, it is now a breeze, okay? So here's what we say. Because we have a 2x minus 3 on top and a 2x minus 3 on bottom, those two things cancel. And our reduced form of this is going to be f of x is equal to 2x minus 3 over x plus 4. Now, it's from this parentheses right here, let me switch colors, this factor that cancels, this is where you get, this factor that cancels, this is where you get the hole in the graph. And in red, this factor that is uncanceled, this is where we get our vertical asymptote. So I'm going to pause the video, and we're going to find both of these in just a second. But I would ask you to pause your video and finish taking your notes so you're all caught up. Okay, so how in the world do we find the hole? Well, you take your factor that canceled in the denominator, because remember, we only care about the denominator, and we have this 2x minus 3, and we want to find out where that factor is actually equal to 0. So I will add 3 to both sides, add 3 to both sides. I have 2x is equal to positive 3, and of course I divide both sides by 2. And here we say, you know what, x cannot equal 3 over 2. So that's where we find our hole at. Okay, how about in red, how about our vertical asymptote? Well, we find our vertical asymptote where x plus 4, remember everything that's in the denominator, we find out where it cannot equal 0 by setting it equal to 0 and solving for x. Well, we'll subtract 4 from both sides, and x is equal to negative 4. Now, it's from these two things. All you have to do is say, hey, you know what, this one is smaller. So remember, a negative number is always smaller than a positive number. And all that means is you just put it first. So here is our domain. Remember, this graph will always go towards negative infinity. And we hit our first smaller number. We hit the vertical asymptote first. We hit negative 4. And at this point, our graph breaks. Our graph picks back up on the other side of negative 4, and then our graph goes from negative 4 all the way to positive 3 over 2, and then check it out, our graph breaks again, and then our graph picks back up at 3 over 2 all the way to positive infinity, and there is our domain. And that's it. Our domain is from negative infinity to negative 4, union negative 4 to 3 over 2, union 3 over 2 to positive infinity. Now, just as kind of a bonus, I just want to show you how to find the horizontal asymptote for these fancy things. I'm not sure if they'll ask this or not, but it's super easy. For the horizontal asymptote, all you do is divide the leading coefficients. Really, really simple. Okay, so my leading coefficient here is 4, and my leading coefficient here is 2, and 4 divided by 2 is 2. So we have a horizontal asymptote at 2, or aka we would say at y equals 2. Okie doke, but the main thing that I want y'all to know is the domain. So good luck with this, and you have 4 practice problems on the next page.